Hello, this is Mr. Collier, and today we're doing some implicit differentiation problems. Okay, so let's take a look at this equation here. On the left, we've got a quantity in brackets squared, so we know that the derivative of x squared is 2x. So the same thing's happening here with this 2. This derivative is going to become 2 times, but our x in this case is the entire thing in the brackets, so that stays exactly the same. Then you gotta do chain rule, so you gotta multiply by the derivative of what's inside the brackets. So let's do that. Derivative of what's inside the brackets, and we're doing implicit differentiation. So this is going to be product rule, because we got x times y. We use product rule because y is a function of x, so you're multiplying two functions here. So first of all, the derivative of x is 1, so the first part of your derivative when we're doing product rule is going to be 7y. Plus, and then 7x stays the same, and the derivative of y is dy dx. Okay, so that's done with the left-hand side. The right-hand side is simply 28, and the derivative of y is dy dx. Okay, so what's next is we might want to expand the brackets. However, you could probably divide both sides by 2 to get rid of this 2. First, and you get a 14. You can also divide this side here by 7. So it's going to be a little bit easier after that. You're going to have 7xy plus 4 times y plus x dy dx equals 2 dy dx. And then we have to expand the brackets because we have to solve for dy dx. Okay, so it's just regular old expanding. We'll get 7xy squared and 7 x squared y dy dx. Then with the 4, so we're going to have 4y 4x dy dx equals 2 dy dx. Okay, so we want to solve for dy dx, so we want all of our dy dx's on one side and the other stuff on the other side. So let's keep this here. And we'll keep this on the left, 4x dy dx. We'll subtract this from both sides. And on the right-hand side of the equation, we're going to bring this to the right-hand side, so it becomes negative 7xy squared. And this thing comes to the other side. Then we can factor out dy dx. So dy dx times this equals the right-hand side. And then just divide and we have our answer. So dy dx equals negative 7xy squared minus 4y over this, and that's your answer. Okay, we got one more example here. X equals secant y, so we're going to differentiate both sides with respect to x. The derivative of x is 1, and the derivative of secant is secant tan. Okay, and because that's a y, we're going to use chain rule and multiply by dy dx. Okay, so you're going to have dy dx equals 1 over secant y tan y. Which I guess you can rewrite it because 1 over secant, well, secant is 1 over cosine, so 1 over secant is 1 over cosine, so it's cosine. And 1 over tan is actually cotan, so we can write that as cotan y.